Hey everybody, I'm going to walk you through some portions of calculating velocity, acceleration, and displacement that's going to come up on our next unit test, which should be in the next couple days. So far, we have a poorly tuned car can accelerate from rest, and we know that rest means it is going at 0 meters per second. They go to a speed of 28 meters per second in 20 seconds. Draw a velocity time graph below. So the first thing, we know that time has to go on our x-axis. So I'm going to put time and seconds. Time is our variable, seconds is our unit. And we know that it has to reach 20 seconds. So I have to make a scale. This is 0. And I don't think that there's enough space to do 20 all the way across. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. It's a little crowded, but we can get there at 20 seconds. And then it has to reach 28 meters per second on velocity. So since we're drawing a velocity time graph, we know velocity has to come over here. And we also know that the units for velocity are meters per second. Remember, you have to have a variable, the v for velocity, and a unit, meters per second, for velocity. And we know we have to reach 28 meters per second. So let's see if I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's not enough. So what if I did 4, 8, 12, 16, 17, 20, 24, and 28. It looks like going by fours works. So I'm going to go 4, 8, 12, 16, 20, 24, and 28. And now we have 20 seconds right here. Has to match up with 28 meters per second right here. So I'm going to go 20 seconds up to 28 meters per second. So they went from 0 all the way up to that one in 20 seconds. So I'm just going to draw my line here. It's about as linear as I can get. So the acceleration, you should be able to find the acceleration, which is the change in velocity over change in time. You do this a couple of different ways. You can go final velocity minus initial velocity over time. And if we do that, we have final velocity is 28 meters per second minus initial velocity, which was 0, over the change in time, which was 20 seconds. So 28 meters per second over 20 seconds. Take a moment and calculate that. Okay, so I've got 28 divided by 20, and we're going to keep these to the nearest tenth, so about 1.4. And we've got meters per second squared is our unit. Another way to solve for this is to use the slope of a velocity time graph. So that is y2 minus y1 over x2 minus x1. And if I go up here, this is my to y2. That would be 20, 28. And my x1, y1 would be 0, 0, because that's right up here. So what you would have here again is 28 minus 0 over 20 minus 0. And that's meters per second over seconds. And that still gives you 28 meters per second over 20 seconds. And that is still going to get you 1.4 meters per second squared. Either way you do it is correct. Just whichever way is easier for you. Okay, question number 2. At 0 seconds, a car has a speed of 30 meters per second. At 6 seconds, its speed is 12 meters per second. What is the average acceleration? So we have our average acceleration formula way up at the top here. We've given them to you right there. So A equals VF minus VI over TF minus TI. Remember, F is final, or the last time you've seen something, and I is initial, the first time you've seen something. So, at 0 seconds, this is the first time we see them. That is 0 seconds, so that is my initial time. And I'm going to put 0, so we're kind of working backwards. A car has a speed of 30 meters per second. So the first time we see them, they are 30 meters per second. And at 6 seconds, that's TF, 6 seconds, its speed is 12 meters per second, so that's our final velocity right there. So we've got 12 meters per second. Now we need to find out our average acceleration. I would pause the video and see if you can't come up with your solution. 12 minus 30, I'm going to get negative 18. And why is it negative? Because it is slowing down over 6 seconds. So negative 18 divided by 6 is negative 3 meters per second squared. A bear spies some honey and takes off from rest, accelerating at a rate of 2 meters per second, and then reaches the honey in 10 seconds. What is his velocity when he reaches the honey? Okay, so we've got a little tricky stuff going on here. A bear spies some honey and takes off from rest. So this is our VI, and that is 0. Accelerating at a rate of 2 meters per second squared, so this is acceleration, and reaches the honey in 10 seconds. So there's our time. We've got to solve for VF, which is an interesting conundrum. Okay, so bear with me. Little pun intended, because the bear, it's Sunday. I'm easily amused. You have to stick with me here. Okay, so a bear spies your honey. We know that we have our formula of acceleration is VF minus VI over T. Okay, then using a little bit of our algebra, we know that AT, if we had A over 1, will equal VF minus VI. So I'm just going to set it up like that. AT equals VF minus VI. And we need to know how fast he's going at the end. So we need to get VF all by itself. So in order to do that, we have AT to get the VI over. You're going to have to add it. Plus VI is going to equal VF. And if you really wanted to rearrange the formula just a little bit more, we know that VF is going to equal AT plus VI. It's the same thing, it just has the VF on the side that we're used to. So, first, our initial velocity, VI, is 0. So I'm going to go plus 0. Our time is 10 seconds. And our acceleration is 2 meters per second squared. And that is our final velocity. Okay, we know that one of those seconds is going to cancel. So now you are left with 2 times 10. So your final velocity equals 2 times 10, which is, I hope, 20 meters per second. So that's how fast the bear was going when he got to his honey. And as always, there is more than one way to solve a problem. I could use way up at the top, V equals AT. Okay? So I could use V equals A times T. Velocity equals our acceleration, which was again 2 meters per second squared, times our time, which was 10 seconds. Seconds cancel. One of the seconds cancel, I should say. So I just take that 2 out. And then I am again left with velocity is 2 times 10, or 20 meters per second. Both ways work. It's just whichever one is most comfortable for you. All right. Now we have a bus moving at a rate of 20 meters per second, and it slows at a rate of 4 meters per second every second. Create a velocity time graph. Okay, first thing I'm going to do is label my graph. And if I want a title up here, I'm just going to put velocity time graph. That's my title. Velocity is my variable. Meters per second is my unit. Time is my variable. Seconds is my unit. You guys know by now that your graphs are about 5 to 6 points each, and you should know that you have to do each one of these things. So we know our time has to go to 4 meters per second every second. So if it goes up to 20, so this is 0, I'm going to go 4, 8, 12, 16, and 20 for that. Slows at a rate of 4 meters per second every second. So it starts at 20 and it goes down 4 meters per second every second. So this is 1, 2, 3, 4, 5, 6, 7. Don't know how many more I'm going to need, but I'm going to fill that up. So if it's 20 meters per second every second, I'm sorry, 4 meters per second every second. I lied to you guys. This is 4 meters per second every second. 20 minus 4 is 16. So at 16, 1 second, 16. At 2 seconds, that would be 16 minus 4, and that should be at 12. Okay? 2 seconds should be at 12. 3 seconds will be at 8. 4 seconds will be at 4. Hopefully you guys are seeing the trend. So if I did 12 minus 4, that should be at 8. 8 minus 4 is 4. 4 minus 4 should be 0. So you would get that line right there. So how many seconds does it take for the bus to stop? It has to reach 0 meters per second, and it took them 5 seconds to stop. How far does it travel? Now we got to think back about how we solve for displacement, or how far, that's displacement. And we know that displacement is the area under a velocity time graph. So you are going to find this area. And the area of a triangle should be 1/2 base times height. At least it is of a right triangle, and that's what we've got here. So we've got 1/2, or 0.5. I like 0.5 for 1/2 just because it's easier in a calculator. And then we have base times height, and that is our displacement. So we've got 0.5 times our base, which is 5 seconds, and our height, which is 20 meters per second. And again, notice our seconds cancel. The seconds is in the numerator, this one is in the denominator. So now we've got 5 times 20. Hopefully you guys know that that's 100. So we've got 0.5 times 100 meters. So half of 100 meters is 50 meters. So how far did that bus travel? 50 meters. Okay, a physical science student skis down Mount Holly, starting at rest and accelerating at 1.5 meters per second. If it takes them 15 seconds to reach the bottom, create a velocity time graph. Okay, so we need to create a velocity in my units, time, seconds, and I'm just going to title this one skier. Mount Holly starting at rest, we know they start at 0, and they go 1.5 meters per second every second. And we know we got to go up to 15. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, rude. Okay. Not quite enough for 15. So I'm going to go 3, 6, 9, 10, 11, 12, 13, 14, 15. It's not going to take up much room, but it's what we have to work with. Okay. And then, so we go 1.5 meters per second every second. And I'm even going to say scratch that. We're thinking about this a little too hard. It says 1.5 meters per second every second. So our time needs to go to 15. So let's go 2, 4, 6, 8, 10, 12, 14, 16. I don't even like that one. Okay, so I realized that I was kind of a big dumb jerk and I didn't have 15 slides on here, so I am going to extend it, make your life a little bit easier. Not the best, but we will get some good data this way. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and at the end is 15 seconds. All right. So for every 1 second, it goes up 1.5 seconds. So let's see if we have enough. Let's see, to go up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is not nearly enough because we need to get up to around 20. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 meters per second. Okay, so at 1.5 meters per second, so 15 seconds to reach the bottom. Cool. Now I'm thinking. So we've got 1.5 meters per second every second. So it's going to start at 1.5, which is close to 2. At 2 seconds, it's going to be 1.5 plus 1.5. So then it's going to be at 2 seconds, it's going to be at 3 meters per second. And then I'm going to add another 1.5. So now we're at 4.5. 3 seconds, 4.5. At 4 seconds, I'm going to add another 1.5. I've got about 6. 6 plus 1.5 is 7.5. So there we go, just shy of 8. I'm going to add another 1.5, and that's going to be at 9. So we're at 6 seconds, and we're at 9. Plus 1.5 is 10.5. Plus 1.5. Now we're at 12. Hopefully you guys are seeing what's happening here. I'm just taking my time. Plus 1.5. 13.5. Plus 1.5. About 15. So at 10 seconds, I'm at about 15. Plus 1.5 should be about 16.5. Plus 1.5, 18. So 12 seconds, I'm up to 18. Plus 1.5, 19.5. We got to get all the way through 15 seconds here. So if you haven't found that linear line yet, you might want to do that and see where it kind of crosses. So we've got 19.5 plus 1.5. We've got 21. So we're at 14 and right up here. Plus 1.5 is 22.5. Check that, 22.5. So we're right about there. And the end isn't perfect because my lines over here aren't perfect. So there's my velocity time graph that it said to create, and I can do a line all the way up here. And now we need to find the total distance that the skier traveled. So the total distance that the skier traveled, and I think you guys might have that on a separate sheet. Mine got cut off a little bit. So we have, okay, I took a moment and printed another copy here. So the total distance that they traveled, again, if you remember back from up here or any of the other worksheets that we did, in order to find how far it goes, you have to find the area under the velocity time graph. So we're going to use this area. So you've got a velocity time graph, so we're going to use this area here. Okay. And we are going to go distance or displacement equals 1/2 base times height. So we've got 1/2, and our base is what? Okay, so up in our question, it did say that they had 15 seconds, and that's our base. 15 seconds. And our height, in order to hit 15 seconds, was at about 22.5. If we remember from our last calculation, is about 22.5. And that is meters per second. Again, seconds will cancel because one's in the numerator, one is in the denominator. And you should pause to try to figure out what this is. So you should get about 168.75 or 168.8. If your numbers can be rounded to an answer that's on your test, you should be able to do that. Okay. So first thing, we have a motion map now. So create a motion map. And we're not going to do one for every second on this one. I just want to see the trend. So we're got to get somewhere up to 168 meters up here. So I'm going to go, let's see, if this is 0 meters, this will be 25, 50, 75, 100, 125, 150, 175, and that would be 200. Something like that. As long as we have a scale that reaches 168, or I'm sorry, yeah, 168.75, that's all that matters. And we know that that's where they're starting. So time of 0 seconds, because remember, we always have to start with 0 seconds on our motion map. Okay, we've got very slow acceleration here, and then they're going to get faster and faster, so they need to have bigger vectors, and then bigger vectors. Okay, so they should be getting longer and longer. A mountain goat starts a rock slide and the rocks crash down the slope at an acceleration of 10 meters per second squared. So I've got an acceleration is 10 meters per second squared, and the time is 5 seconds. What is their velocity that they reached the bottom? So we need to find out the velocity where they reached the bottom. So again, if you wanted to use a triangle, V, A, T, that can help you get your idea for what to do. You could divide there if you needed to, and if they're next to each other, they multiply. So we're looking for their velocity, which is this guy. So I have to say V equals something. And so now that I have V, I'm going to cover that up. I am left with A times T. So that's my formula. A times T. My acceleration is 10 meters per second squared times our time, which is 5 seconds. One of those seconds cancels. So my velocity is going to be 10 times 5, or 50 meters per second. That is one way to do it. Or if you like the fancy version, you can have A equals BF minus BI over T and shuffle for final velocity like we did on a previous question. I think it was on the first page. Yep, down at the bottom here. So you can use this formula here on the first page, and that would also do it, whichever one is more convenient for you. And it just a lot of times will depend on my mood. So to shuffle this, it is BF equals AT plus BI. My acceleration is 10 meters per second squared. My time is 5 seconds, and my VI is 0 because it was at rest. So I am still left with 50 meters per second. Both ways work. Okay. I hope you learned and are able to study a little bit for this.